And engineers also have to use certain technical terms. They have to understand basic forces that are involved in vehicles' motion. So we will review some of these basic physics terms. First one is called centripetal force, with a P. And basically, centripetal force is defined as a force pulling an object towards the center of a curve, causing what's called curvilinear motion. So if we're driving along the road and we turn our wheels to the right, it's the spinning wheels that pull our car into that curve. Regardless of whether it's a front or rear wheel drive, the wheels must be turned in a direction that we want to go, and the wheels must be spinning. In order for that to occur, we call that force pulling it towards the inside of a curve centripetal force. The second force that engineers have to deal with is what's known as centrifugal force. Centrifugal force really is an imagined force. It's not really a force, but it's relating to Newton's first law of motion. Centrifugal force is a force pulling a vehicle towards the outside of a curve. So again, if we're making a turn, centripetal force pulls us into the turn. Centrifugal force pulls us towards the outside of the curve. And as we all know, if we go too fast, centrifugal force can overcome centripetal, in which case the vehicle does not make the turn, but instead continues in a straight line towards the outside of the curve. Now, a key concept that I want to emphasize is that in order for centripetal force to pull a vehicle into a curve, two things must occur. The vehicle will always follow the directions of the wheels. So if the wheels are turned to the right, the car will go to the right. However, in order for that to happen, the wheels must be spinning, and they must have grip. If the wheels are not spinning, such as a brake lockup, the car has no centripetal force. So regardless of whether we turn the wheels to the right, the car will not turn to the right, but will actually skid straight ahead. That's the advantage of having anti-lock brakes. You can still steer and stop at the same time because the wheels never lock up. Now there's another issue here, and that's the fact that centripetal force and centrifugal force sort of act against each other. And speed does affect which one is going to win. As we go around a corner at a reasonable speed, centripetal force wins. So the car goes in a nice smooth turn. However, as we increase speed, centrifugal force becomes more than centripetal. And as a result, the vehicle will go further and further towards the outside of the curve. All right, we're going to talk about a couple other terms that we need to understand this. The next term we need to understand is known as inertia. We've all heard of Newton's first law of motion. Basically, it says a body at rest will remain at rest unless some force acts on it. A body in motion will continue in motion until some force acts on it. In this case, it's friction. So inertia just means a body at rest will remain at rest, a body in motion will continue in motion at the same speed unless an outside force acts on it. Now, there are two types of inertia. One is called static inertia. Static means non-moving. So again, a body at rest will stay at rest until a force acts on it. The second inertia is dynamic inertia. And dynamic inertia says a body in motion will continue in motion unless some force acts on it. So a car will continue in motion until something stops it. Okay, in this case it would be friction. Now another term that we need to discuss is called momentum. Momentum is really just a mathematical term describing inertia. Momentum is the result of mass times velocity. As we increase the mass of an object, it will have more momentum. As we increase the speed of an object, it also will have more momentum. The next term that engineers have to be aware of is what's known as kinetic energy. We've all seen these in our textbook. It's part of our state test questions. Kinetic energy is defined as 1/2 the mass times the velocity squared. Velocity meaning speed, mass meaning the weight of the vehicle. Okay, what this tells us is, as you double the mass of a vehicle, you double its kinetic energy. As you double the velocity of a vehicle, you quadruple the kinetic energy because of the square factor of v squared. Ke equals 1/2 mv squared. As you triple the velocity, the kinetic energy becomes 9 times as great, 3 squared, and similar 4 squared and 5 squared. So velocity becomes more and more of an important factor in terms of giving a vehicle kinetic energy. And what does this kinetic energy do? Well, in an impact, it transfers that momentum or kinetic energy to the vehicle that it hits. So the more kinetic energy it has, the more forceful the collision. For example, an 18-wheeler has tremendous mass. When it hits another object, it's going to transfer all of its kinetic energy to that object. By the same token, a car traveling 100 miles an hour will have a tremendous amount of kinetic energy due to its speed, even if it's a light sports car.
Okay.
The next term we have to take into account is grip. And grip merely means the amount of friction between the tires and the road surface. Asphalt usually gives us the best grip. Icy roads, snow, wet roads give us less grip. There's only 4 points on a car which control the direction the car is going to go. And that's called the paw print, which is only about the size of my fist. And that is what contacts the road. Grip becomes very important. Loss of grip means loss of control from the car. Now, these next two terms are what engineers work with to try and overcome a bad driving habit or a bad driving situation. One is called oversteer. Electronic stability control tries to overcome a car's path of travel and give it its intended path of travel. For example, if a car is making a turn and it makes the turn too fast, or if it loses traction, what often happens is the car oversteers. The back end tends to catch up with the front end. The way we counteract this before we had analog brakes and traction control is we were taught to turn in the direction of the skid. In this type of oversteer, it's the back wheels that are skidding in this direction. So we would say the back end is skidding left. We would turn our steering wheel to the left. We also say look in the direction of the intended path of travel. If the car is going this way, we want it to go this way. So we look in that direction. Also, we're taught to give a little bit of throttle control. What throttle control does, it puts a little more pitch on the back wheels, and therefore the back wheels will maintain a bit more grip. All right. The last term we're going to consider is called understeer. Understeer occurs when you want to make a turn to the right, but the front wheels lock up, either due to extreme braking, and even though the wheels are turned to the right, the car has no centripetal force because the wheels are not spinning. Therefore, Newton's first law of motion says that the vehicle will go straight, even though the wheels are turned to the right. That situation is known as understeer. Stability control corrects for these two driver errors. And later on in the program, you will read about specifically how it does it. There are sensors involved, there's a computer involved. It involves differential braking for the four wheels. It involves throttle control, and also involves measuring the steering angle. And stability control is one of the latest new technologies that we have.